morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Stefan from Business Review, and I will be your host. It is our pleasure to have Donaldson Filtration Systems with us today, representing the webinar titled Dust Hazard Analysis. Today's guest speaker is Chrissy Walker, Application Engineering Manager at Donaldson Filtration Solutions. Since 1915, Donaldson Filtration Solutions has been solving the world's most complex filtration challenges with innovation for every industry. Their industry-leading technology provides advanced filtration for optimal performance along with a wide range of filtration media, including over 90,000 filters and parts in stock and ready to ship. And live technical specialists at over 40 global locations provide you with unparalleled support. No matter your industrial filtration requirements, they have the right solution for you. But quickly, let's get into some housekeeping stuff. Before we begin, I'd like to welcome you to our webinar platform On24. You notice that this webinar is browser-based. If you happen to disconnect for any reason, you can just click on the link you received via email to rejoin the session. To ask questions, you can do so via the Q&A widget on the top right-hand side of your screen. Just type your question into the box and click Submit. We'll allocate some time at the end of the session to address any questions or thoughts that you may have. You can also find useful resources for download from the widget located on the bottom left of your screen. Please use the yellow help widget if you require any assistance, and please keep in mind you can move, resize, and maximize all the windows in front of you for a better view of the slides. But now please allow me to welcome Chrissy.
Thank you, Stefan. And again, welcome everyone, and thank you for joining our discussion today. We will be exploring the 5 major steps of a dust hazard analysis. But before we begin, I'd like to get a quick understanding of everyone's experience so far with a dust hazard analysis. So Stefan, I'm actually going to toss it back to you for a brief polling question.
Thank you very much, Chrissy. So our first polling question for today reads, has your facility conducted a dust hazard analysis? The options are not yet, yes, we've just started, yes, I think we're complete, and I'm not sure. Chrissy, is there any particular reason why you chose to ask this question?
Yeah, so everyone's talking about dust hazard analysis right now, and with the date now past September 7th of 2020, that was given to us by NFPA 652, a lot of people should be completing or should have completed a dust hazard analysis. So I'm just kind of trying to understand from our audience today where everyone is at, if they've started or not.
Okay, lovely. Thank you very much. And now let's take a quick look at the results. So the audience is pretty split here. 30% voted on not yet. 30% selected yes, we've just started. Another 30% chose yes, I think we're complete. And 10% voted on I'm not sure. What are your thoughts on these results?
They're pretty much where I expected them. I think a lot of people haven't started their DHA yet because it can be quite an enormous task given the size of their facility. But then also once you start diving into the DHA process, as we're going to find today, there's a lot of things you can do kind of pre-DHA and then post-DHA. There's a lot of work that sometimes takes a lot of financial capability and resources and also just time to complete. So the results are actually exactly where I kind of expected them to be.
Perfect. Thank you very much.
All right. So like I mentioned, the actual assessment of your facility, it could be completed in one day or maybe over 1 week, depending on the size of your facility. But there's work that can be done leading up to this day, and there's definitely going to be work that has to be completed following the results of the analysis. So after today's discussion, we hope you'll walk away with a better understanding of determining and documenting combustible dust risks and potential hazards within your plant, understanding industry standards and codes associated with your process, identifying mitigation actions to mitigate the risk, such as creating a risk management plan and then executing on those recommendations, and the importance of managing and modifying the plan as changes happen within your facility. Then we'll close our discussion today with how Donaldson can help you with your DHA process. So To start our discussion, let's define a dust hazard analysis, or DHA. A DHA is now becoming more recognized as a prerequisite when dealing with combustible dust and as the first step in selecting mitigation strategies. The DHA offers a method for plant or facility owners to identify specific combustible dust hazards within a process or operation and address and document mitigation strategies that can be used to manage risks to a tolerable level. In its most simple form, the DHA consists of identifying hazards, documenting the potential risks, and determining actions to mitigate the risks. For many facilities, hazards may include the combustible nature of a fume or dust produced or handled in their process. They may also be present where there is an interaction between materials, even if the materials don't present a hazard when they're alone. And while hazards may be inherent characteristics of the dust, risks represent the potential measure of human injury, environmental damage, or economic losses, which could result if an injury or an incident were to occur, and they're typically associated with specific risk scenarios. Once these are identified and documented, the purpose of the DHA is also to determine actions which have or could be taken to address the risks identified in the process. There are, in essence, 5 major steps to the dust hazard analysis. The first step is to get informed, both on the characteristics of materials being handled or produced in a process, and on what codes or standards of practice may apply to a set of processes or materials. The second step is to determine what risks may exist in operations and processes. This includes establishing a clear understanding of both the potential consequences and the potential circumstances which may lead to an incident. The third step is to summarize potential scenarios which could result in a risk. Then determine if the resulting risk is at an acceptable level or if further action is required. Because this step requires understanding of a process and knowledge of relevant codes or standards, a team of resources may be needed. Now, the summary report of risks and actions is sometimes mistaken as the result of a DHA. However, there are 2 still remaining steps that have to be taken. The fourth step is to execute on the actions and recommendations from the report. Simply knowing what actions should be done is not actually going to reduce the risk. You have to create a plan and follow through to completion. And the fifth and final step is follow-up. This step confirms the actions have been completed and communicated to interested parties. It also involves updating a dust hazard analysis to address any process changes. And even if no changes occur, good practice is to review and update a DHA at least every 5 years. So let's dive in with step number 1, gathering information about your process. Regardless if your dust is combustible or not, you want to be informed on the materials which will be handled or produced in the process. This includes understanding where dusts are produced and where they represent risks, such as overhead structural supports or transfer points within a process. Keep in mind that some materials may present different hazards when physically changed or when they are mixed with other materials. Obtaining accurate information on the actual hazard characteristics of the dust is very important. The outcome of this data often has a direct influence on the selection of mitigation strategies. Prior to submitting dust for testing, ensure the samples are highly representative of the dust present in the process. Samples should reflect the physical characteristics likely to produce the most risk. When different dusts are blended, samples should also represent the most likely combination of mixed material. So let's walk through a fictitious example. In this case, we have a production team who started assembling a list of materials that are produced within their facility. They've done some research to understand the hazards for many of the materials, and they're going to continue to expand their list as manufacturing advances. By having reported KST and Pmax values for some of their materials, we can already see that several dusts are combustible and represent fire, flash fire, and/or explosion hazards. These values are extremely helpful in sizing and selecting explosion mitigation devices. You'll see on the list that the dust from the abrasive blasting process is currently being sent out for evaluation. While the production team waits for the results, they're going to take a conservative stance and assume that this will be combustible until the test results show otherwise. Now, this is also a very reasonable approach for any customer who's planning a project and doesn't quite have dust to test yet. Some of the data they're collecting, such as minimum ignition energy, or MIE value, may be helpful in determining electrical classification areas or special bonding or grounding requirements. And the minimum explosible concentration, or MEC values, may help identify where sufficient fuel is available to create a risk that requires mitigation actions. In addition to getting your dust tested, the other aspect of getting informed is being familiar with local codes and requirements. This includes learning any specific code or standard recommendation for the materials you are handling. There are a number of codes and standards published by the National Fire Protection Association. There are also FM Global Property Law data sheets and international fire, mechanical, and building codes published by the International Code Council, or ICC. Each of these codes and standards may exist at different editions, and some earlier editions may be the current legal requirement for where a facility is sited. It's good practice to understand if a more current edition exists, as these may offer different strategies for risk reduction. So now that we're informed on the process-related hazards, let's determine the potential risks. On to step number 2. With an understanding of the hazards present and some knowledge on the applicable local regulations, codes, and standards, process owners are armed with the information they need to start assembling a list of combustion hazards and the resulting risks. As each risk is documented, consider what level of risk each hazard situation may represent. This will also help in prioritizing mitigation strategies. To accomplish this, consider several factors for each hazard scenario. What could go wrong? This includes foreseeable events which may occur during normal operation or maintenance, as well as during servicing of related processes or equipment. It should also include an effort to identify any other unique conditions which may occur during upset conditions or as such an emergency shutdown. Next, consider the potential impact or consequence which may result during or following such an event. Include considerations for potential injury, equipment or facility damage, and possible work disruption. Then ask yourself, how likely is that event to occur? To answer this, try documenting the sequence of conditions which result in the event consequence. For example, dust accumulations become suspended in the presence of a bearing which overheats, resulting in a flash fire or deflagration at that location. Understanding this sequence may provide some insights into how to prevent such a chain of events from occurring. Answers to these 3 questions provide the insight needed to establish a level of risk for each scenario. From there, determine which scenarios need to be addressed most quickly to reduce all risks to an acceptable or tolerable level. For combustible dust, there are 3 general categories of risk that should be considered: fires, flash fires, and explosions. For each of these 3 risks, create a list of potential events and their consequences. The list should consider multiple scenarios, such as during normal operation, startup and shutdown sequences, and during maintenance or potential upset conditions. The list of potential events should address not only the process system, but also any broader consideration for conditions within the facility at large, and specific considerations for each unique piece of process equipment. For example, it's difficult to execute a good dust hazard analysis if you focus exclusively on the dust control system. One method for evaluating risk scenarios would be to consider how each side of the explosion pentagon might contribute to the scenario in terms of likelihood or consequence. For each risk scenario, consider what steps are already in place to reduce the risk and how these steps address each side of the pentagon. Do risks still remain after all sides of the pentagon have been addressed? Or are the residual risks at a tolerable level? If they're not, are additional actions available that could be taken or advised? And as each scenario is profiled, note what risk reduction actions are already in place and then what steps are already planned. These should be well documented, including details of who will be responsible and the timing for implementing each action. It's basically impossible to eliminate the entire risk. So once that information is available, determine the relative level of risk that remains. One method uses a 5-color scale to differentiate the level of remaining risk from as low as reasonably possible to very high, meaning activity should be ceased until the risk can be addressed. Many of the activities and processes will have a residual risk even after deploying a variety of risk mitigation actions. The question you then want to ask is, have those risks been managed to a tolerable level? So now that we've documented the risks, step number 3 is to identify actions or recommendations that can be used to reduce the associated risks. When documenting what risk reduction actions could be considered to address any residual risk levels, take credit for actions which have already been deployed. For example, there may already exist an explosion vent and passive isolation valve on the inlet of the dust collector that's located outdoors and is exhausting the clean air to the atmosphere. This ensures a record of those actions in case someone decides to reverse them in the future, like deciding to return the air back into the facility. Then, identify any potential changes in current practices. These might be relatively simple or whole-scale adjustments. And finally, consider what new actions could be taken in addition to what is already being accomplished. As was just mentioned, where possible, it is great to have these new recommendations planned out with priorities, milestones, and owners to ensure that they are acted upon in a timely fashion. The risk of an event scenario can be weighed in part on the severity or consequence of the event and the relative likelihood of the event from occurring. After all, an event that is highly unlikely to occur may not rise to the same risk concern as a likely event, even if the highly unlikely event has a more severe consequence. This image of a likelihood and severity matrix provides one example of how one might rank the various risks they've identified. As mitigation actions are considered, keep in mind that most strategies either strive to reduce the likelihood using prevention methods, or they strive to reduce the consequence using protection methods. In either case, the result is to shift the residual risk to a lower risk category. The use of consistent internal definitions for severity and likelihood allow a process owner to start considering the level of risk represented by one scenario against another. Now, at this point, some might consider a DHA complete, as you now have an existing report that outlines the current risk scenarios and a list of current and recommended actions to reduce those risks to a tolerable level. However, the DHA is far from complete if the recommended actions aren't actually implemented. So step number 4 in the DHA process is to execute the actions that we've identified in the earlier steps. Prioritizing which actions to take may be easier with answers to a few questions for each scenario. Is the risk at an acceptable level or a tolerable level? Are there steps in place to reduce the risk towards a more tolerable level? What changes could be made quickly, and what changes would take longer to implement? And if you wait, will the longer approach provide more risk reduction? Remember, the intent is to reduce risk to a level that is as low as reasonably practical. As we mentioned earlier, documenting the details of the risk mitigation plan is essential. What actions will be taken, by whom, on what timeline, and how will it be clear the actions have been taken? It's also a great idea to document any actions determined to be not appropriate or necessary. Documenting the reasons an action is not taken can help establish comfort with the decision and will eliminate future questions of why strategies were not implemented. And finally, how will you determine if the strategies are effective? Well, the easy answer is the effectiveness is partially measured by the absence of any events. However, certain situations are prone to potentially change and challenge those actions. This includes any change to the process, from a change in the materials you're working with to a change in the equipment and dust collection system layout. So step number 5 of the DHA is to follow up on this living document. But before we go any further, I'm going to stop us one last time for another short polling question. So Stefan, I'll toss it back to you.
Thank you very much, Chrissy. So this polling question reads, do you have an established combustible duo training program at your facility? This training program, excuse me. The options are yes, no, not sure. What results are you expecting on this one, Chrissy?
Well, I'm hoping that, majority of the answers are yes, but I'm going to be surprised to see just kind of how even between yes and not sure.
Okay, lovely. And now let's just take a quick look at the results. So 60% voted no and 20% voted yes, and the same amount voted on not sure. What are your thoughts on these results?
It's a bit surprising, but I do think NFPA and combustible dust hazards are a topic that, facility owners are still kind of just struggling with. And, it's always one of those that it's out of sight, out of mind. Until someone has an event, they keep thinking it's not going to happen to me, so I don't have to worry about it. And so while I would hope that the majority would say yes, I guess I'm not surprised that 50% say no on this topic.
Fair enough. Thank you very much, and thanks to the audience for voting. So I'll hand over to you for the rest of the presentation.
Great, thank you. So it's important to review your risk scenario. Anytime changes are to be made to the process, things like, are current actions still going to be effective, or will the new situation create scenarios that were not previously considered? Or does the new situation now eliminate risks that weren't present before? One sure sign the risk reduction strategy needs to be revisited is an event or a near miss. Now, we've already acknowledged the likelihood of residual risks, so we knew events might still occur. However, when such events occur, are the outcomes consistent with your prior expectations, Or does the risk profile need to be reevaluated? Was the consequence more severe than anticipated, or did the recent event suggest a higher likelihood than expected? It may also be that the most telling questions are around the behavior of our risk reduction strategy. Did the actions taken actually reduce the severity or likelihood as we anticipated, or is the current strategy and outcome acceptable, and are additional risk reduction actions necessary? In the case of an event, the other thing facility owners should be verifying is their communication strategy. Most NFPA mitigation devices require an alarm function. So if you have an event, you'll want to validate if the proper alarms were activated. And if so, did the employees know and understand what needed to be done? And if the unfortunate answer is, well, no actions were taken, well, then you may need to establish more ongoing training and awareness programs for your employees. And for many of you on this who don't have training programs established, maybe it's something to think about as you develop your DHA and your mitigation strategy. And finally, even if no changes to the process have taken place and no events or near misses have occurred, process owners should still review their DHA at least once every 5 years. This provides them an opportunity to confirm that documented scenarios are still representative of the operations in their facilities, and it also allows for a review of current standards and regulations, many of which are updated every 3 to 4 years and could impact current mitigation strategies. So the extensive amount of work that goes into preparing for and executing and maintaining a dust hazard analysis is not an easy feat. It's recommended that when performing a DHA at your facility, work with a team of stakeholders who will provide the best opportunity to identify risk scenarios and then capture both current and recommended mitigation actions. Implementing the mitigation strategies also requires a team effort. For example, training of employees and preventative maintenance for equipment are both ongoing activities that should occur as people and processes change. So how can Donaldson help you? Well, to start, we serve a variety of industries, from metal fabrication to grain, mining to woodworking. We have the expertise to assist you with your local exhaust system ventilation needs. And within each industry, we have the products and technologies available to suit your specific application needs. Whether you're looking to upgrade your existing bag house, or you're in need of a cartridge collector for your new process equipment, or you simply want ambient filtration units to supplement existing engineered controls, we offer a vast product line that can be customized to complement your mitigation efforts. When it comes to selecting mitigation solutions, just like dust collection, it's not a one-size-fits-all approach. We at Donaldson understand the impact that dust types and hazard characteristics have on mitigation solutions. And together we will work with you to tailor your dust collection system solution and mitigation strategy to fit your unique needs. After designing and installing a dust control system, you'll find that it's not a one-and-done purchase. Most equipment requires periodic servicing and maintenance, which in turn keeps your production up and running longer. And when operational practices change, this can lead to additional servicing or monitoring needs, or even the purchase of new equipment. So wherever you are in your dust collection and hazard mitigation journey, Donaldson has the people and resources available to support you. So in summary, a DHA is a powerful tool that process and facility owners can use to improve safety initiatives within their plant. They offer a method for documenting combustible dust hazards and the potential risk scenarios and identifying mitigation actions, both those already being utilized and those that could be added to help reduce risk levels to a tolerable level. When preparing for your DHA, it's important to recognize and understand what codes and standards apply to your process. This information may play an important aspect in the selection of mitigation equipment and strategies. Once documented, create a detailed action plan to execute the recommended mitigation strategies, and be sure to follow up to verify tasks were implemented. This may include the purchase of new equipment or the creation of new administrative requirements. When changes take place, be sure to modify and update the risk management plan as needed. Even small changes, like opening a damper on a piece of ducting, can impact a risk scenario. And finally, there are many resources available to help you. Equipment manufacturers, third-party risk analysis companies, or even your local fire marshal or insurance agent. A DHA should be a team effort, and we're here to help you every step of the way. To help get you started, we've provided several resources available in the Resource tab at the bottom of your screen. So, Stefan, I'll open it up to you to see if there are any questions from our audience today.
Thank you very much. And it is now time for the Q&A session. If you'd like to submit your questions, you can do so via the Q&A tab on the bottom right-hand side of your screen. Just type your question into the box and click Submit. But it looks like we have some questions coming in already. Our first question for today is, how do I complete my DHA if it's for a new process and there is no dust to get tested?
Yeah, that's a great question. I showed that slide where in the example, they kind of just assumed their dust was combustible. There's a lot of great information out there on dust testing, and sometimes you can even just do a quick Google search to see if dust has been tested as combustible. One of the best ways to go about this, though, is to assume that your dust is combustible. And there's resources for guidance in terms of KST and PMAX levels in the back of NFPA 652 to give you an idea if different types of dust have been tested as combustible. But if you have absolutely no idea, the best approach would be to assume it's combustible. A lot of the mitigation actions and provisions that you're going to have to take are a lot easier to implement if you can be proactive and do it on the design stage, rather than retrofitting equipment and controls for that equipment into an existing system.
Thank you very much for that answer. And moving on to our next question for today. Does Donaldson do DHAs?
Yeah, so there are a lot of great third-party risk assessment companies out there that will perform and facilitate a DHA assessment. And having participated in several DHAs, I find that sometimes those risk assessment companies don't quite have the level of understanding that of a specific dust collection system in terms of how our equipment or an industrial ventilation system is kind of designed. And so what we find is we provide a lot of valuable information on the actual dust collection system that is extremely helpful in complementing the risk assessment qualifications that those third-party companies have. And so while we won't actually facilitate the DHA, we do find a valuable partnership when kind of participating and assisting with the process owner, the third-party company, end users and employees in doing that entire risk assessment. So we see ourselves as more of a partner rather than a facilitator of a DHA.
Thank you very much for that answer. And just another quick reminder to the audience, you can still send your questions in via the Q&A widget. But moving on to our next question for today. What risks could we find into the very dust collection system which could be as dangerous as any event that can occur into the production area?
Yeah, so one of the goals of the mitigation strategy is to avoid that secondary deflagration. So a lot of times there may be a deflagration or event that happens within the dust collection system, which obviously we want to avoid and protect for as much as we can. But the damage, what happens if there's a secondary event, those are the ones that have caused catastrophic damage, and they've taken down the Imperial Sugars and the West Pharmaceuticals and some of those bigger names. Those kinds of events, we want to look at housekeeping measures, because if you have a pressure wave that isn't isolated and gets out into the actual facility, if there's residual dust laying around on the production floor or up on structural beams, the pressure wave can disturb that dust, and as it falls to the ground or it gets agitated, it can now become dispersed, and if it's followed with flame and particulate, that's where you get your secondary deflagrations. So we want to look at those mitigation strategies that will prevent and protect from the initial event, but we also want to help manage the secondary events. And part of that is administrative controls in the production area, like housekeeping and, electrical classification areas if required.
Thank you very much for that answer. And our next question reads, is it necessary to get dust tested if the vendor already has it on the SDS document that dusts are combustible and explosive in dust form?
Yeah, this is a great question. So a dust is deemed combustible if it has a KST value greater than 1. Anything greater than 1 is combustible. The reason why you want to have your dust specifically tested is, number one, to determine what level of combustibility do you have. Is the actual KST, is it 50? Is it 200? Is it 300? And the reason that's important is because mitigation equipment is often limited to a specific KST and Pmax value. And so it can't be used if it's greater than 300 or something like that. So the first one would be to kind of figure out the level of combustibility to make sure that the equipment you're using is suitable for that dust. The second reason is a lot of times, especially with metal dust, if you're dealing with a metal dust, there are certain tests that isolation equipment, for example, has to be tested specifically on metals. And so you want to make sure that by getting it tested, you can also find out different mitigation strategies or extinguishing agents for fire. And so that will give you a little bit more insight to picking the appropriate mitigation solution rather than just saying it's combustible and explosive.
Thank you very much for that answer. And just one more reminder to the audience, you can still ask your questions through the Q&A widget. But moving on to our next question. How do KST and Pmax values impact mitigation strategies?
Yeah, so I just kind of mentioned this one. Mitigation strategies are often limited in terms of, kind of their allowable KST and Pmax values. For higher explosive or more combustible dust, if you have a KST around 300 or 350, sometimes those types of materials might require multiple mitigation strategies. You could use chemical suppression in addition to explosion venting, or you just may require a lot of chemical suppression or, a lot of vents, which could be very challenging to put on your dust collection system. So isolation valves are also rated a lot of times for KST and Pmax. A higher KST value is going to have a very fast pressure wave. And so you want to make sure that the isolation device can activate or close in time to prevent that flame and particulate and pressure wave from getting back down the inlet duct.
Thank you very much for that answer. And I believe we have time for one or two more questions. So this question reads, how do you organize a DHA?
Yeah, there's no right or wrong way to organize a DHA. It kind of depends on the person, but and the size of the facility. If you have one single process, it may be a lot easier to kind of make sure that you have all of the documentation. It may be that you have drawings and a lot, it's either like a folder, or you could have a 3-ring binder, or even just an Excel spreadsheet that kind of goes through it. But as you go through however you organize it, you want to make sure you cover, okay, what information do we know up front? Do we have all of our existing manuals? Do we have our drawings and kind of the design that goes into this? And then what do we know about the different risks that are associated with them? And so sometimes this can be flowcharts, or I've seen spreadsheets that kind of step through process 1, risk 2, mitigation strategy A, B, C. And so there's no right or wrong way. It kind of depends on the person and kind of how they themselves kind of stay organized.
Thank you very much for that answer. And as I mentioned, that's all the time we have for today. If you didn't get your questions answered today, please keep in mind they can be answered at a later date offline. So just leave me to thank Chrissy for the great presentation and to Donaldson Filtration Solutions for sponsoring this session. To the attendees, you will receive an email shortly with instructions on how to watch the on-demand version of the webinar. We can do this on our website, which is www.business-review-webinars.com. Thank you very much, and I hope you have a great rest of your day.